Hello there, everyone, and welcome to this workshop on an introduction to data engineering with Python. My name is Valentine, and I'll be your instructor. In this course, we're going to learn how Python can be used for data engineering. We'll explore a few examples and generally set the foundations for this learning journey that you might be interested in. So it could be that you would want to become a data engineer at the very end and you're not sure where to start. Then this learning experience should form the basis of that learning journey. So after this workshop, you should be now confident that data engineering with Python using this tool is probably something that you'd want to undertake. So in this learning experience, we're going to follow this structure. We'll get started with the learning outcomes. After that, we'll talk about what data engineering with Python entails, why we would want to learn about Python when it comes to data engineering. Then after that, we'll get into a practice session that involves implementation of Python. So we'll actually create what data engineers create. So we'll create what are called pipelines, and we'll use Python for that. Some basic data pipelines that should give you a sense of what that process entails when it comes to building pipelines. Then after that, we'll talk about the next steps towards the very end. Starting off, by the end of today, we expected to have understood these learning outcomes, so what we have achieved. So we should be able to describe the role of data engineering in data lifecycle. We should also be able to construct what are called data pipelines, which are just deliverables that data professionals called data engineers would actually create. So you should be able to construct data pipelines for data ingestion and transformation using some Python libraries. We'll focus on pandas, but we'll also introduce a few more, such as Beautiful Soup for being able to pass data or to just extract data from web pages, etc. And also requests for just being able to pull data from just websites or web servers. We should also be able to differentiate between different types of databases and data storage solutions. We should be able to implement basic data cleaning and pre-processing techniques using Python. And we should also be able to explain the importance of data quality and its impact on downstream analysis and machine learning. Before continuing, it would be important to also mention that this workshop and it assumes that you have some basic understanding of Python, the Python programming language, and have interacted with data before using Python. So having knowledge of working with pandas, so for data analysis, that's the assumption, as well as data wrangling. And that would be beneficial because some of the examples that we'll come to talk about later in the practice session will not really focus so much on how you perform various data pre-processing techniques. We are going to only focus on creating a pipeline and tell you that you can always apply different techniques in relation to data pre-processing or data wrangling for also data for the creation of data pipelines. So the assumption is that you have some knowledge of Python. If not, you can still go through this workshop for about maybe 20 minutes and then go through some of the Python fundamentals as well as data wrangling and data analysis workshops that we have, just to be at par with the learning experience that we have for today. So yeah, that's something to just ensure that just to tell you so that you're ready and prepared just in case you might be lost. So yeah, so let's get started. What is data engineering with Python? So this is a process that involves using the Python programming language to design and develop systems for collecting, storing, processing, and analyzing large volumes of data. So just simply explained, you can think of data engineering with Python as that process that involves collecting data from different data sources. Could be that data has been stored in CSV files or relational databases or in Excel files. So as a expert in data engineering, what you would do is to create what the mentioned systems, which would be what are called data pipelines, which would pull data from those different sources and aggregate the data and perform some sort of pre-processing techniques and then load that data to a destination data source. So it could be that you have multiple files, then you write Python code that collects data from those multiple files, aggregates it, performs data pre-processing tasks, then puts loads that data or saves that data that you've pre-processed in a data source that other stakeholders such as data analysts or data scientists can then pull data from. So the idea of a data engineer is to figure out systems in relation to the data infrastructure and figure those out, how to work with them and how to pull data from those data sources and be able to prepare it for other stakeholders such as data analysts or data scientists. So a data engineer, this professional who would be versed in data engineering, would have knowledge of how those databases work, or in some other situations, they would also need to understand how to deploy those systems that are used for data storage, because in some cases, they might decide to create a certain database and then load the data that they have processed in that particular database. And databases are just containers, large containers. You can think of them as that hold data that you can later onwards use for your own analysis. So as a data engineer, you would be doing the under the hood work of just organizing data for other stakeholders within an organization. Data analysts or data scientists, their focus normally lies on getting insights from data. So they do not necessarily focus a lot on organizing data, ensuring it's in the right format. That's not usually the roles of, that's not the responsibility of data scientists or data analysts, or even machine learning engineers. A data engineer is the one who would organize all of that. But in some context, you might find data scientists or data analysts doing what data engineers would do, because maybe an organization doesn't have budget or doesn't have personnel for performing that task, and they need the data, so they would have to now go into the data storages or the data sources that an organization has, pull that data, and then use it for analysis or put it in another data source that they can later onwards use to now pull data from that data source and do their own analysis. So data engineering just involves that process of designing and developing those systems or data pipelines that we can use for collecting, storing, and pre-processing data. It's important, as you've seen, it's an important aspect of data management and analytics. So a data engineer would do something that would be separate from normally what a data scientist or data analyst would do. The skills that data engineers would need, and data engineers are those professionals that perform such tasks, they would need to learn how to work with different databases. These databases could use they could be relational databases which use SQL for collection of data, or for just being able to perform operations on those databases. It could also be that they might also be versed with some other data sources that are not necessarily relational in nature. It could be that they could work with data sources that are NoSQL. There's a type of database called NoSQL databases, and those databases don't use SQL. They have their own languages. So you might have heard of MongoDB or Cassandra. Those have their own ways of interacting with those data sources, and data is structured not in a tabular format as you would have in relational databases. You'd have data stored in a different format. Data engineers would need to learn how to perform scripting or automation, or just writing code to be able to automate some of the tasks that involve collection of data or pre-processing of data. So the idea would be that, say they pull data from this database, or they can then automate that process of pulling data. That way, that process isn't repeated again manually over time by various stakeholders. So their jobs might, that responsibilities might involve just automation. Data modeling, they would also need to learn how to create what are called schemas or models within data sources. So it's just structure of how you store data within databases, and ensure that the structure is much more efficient, that probably there's no deduplication of data within those databases. That way an organization doesn't spend a lot on storage costs, because many organizations store data in the cloud, and nowadays cloud costs can be really high and sometimes unsustainable. So data engineers would come in and also try to ensure that the infrastructure that's being used is as optimal as possible. They might also be involved in optimizing data pre-processes, stages or tasks. So sometimes some code that has been written by other stakeholders might just generally not be efficient at all. So for example, you might find that data that has been pulled has been stored maybe in one particular data type within maybe a data, not even a database, or even just generally when it comes to data pre-processing. When you work with maybe a Python library like pandas, you might find that in the code that was used to pre-process some data, the assigned data type was int maybe 64, but the data itself can be actually held by a specific sub data type called maybe int 16 or int 8, which actually consumes less memory as int 64. So data engineers can always undertake the process of optimization of those data pre-processing tasks in some context, depending again on the goals of the organization. More on data governance, they would also need to ensure that data is, of quality, that data that is collected is also conforms to compliance or regulations, as well as it's stored in a secure way. So those are some of these skills that data engineers would need to work towards, would need to have in order to perform their day-to-day tasks. So generally, just to summarize it all, why is data engineering important? So this part of working with data ensures that data is readily available and accessible by stakeholders, such as data analysts or data scientists. It cuts down the amount of work that those other stakeholders have to do, and it helps them just focus on creating more value for the organization. Data engineering also helps to allow organizations to combine data from multiple sources. So it helps the organizations or the stakeholders have a unified view of what is happening when it comes to the organization for just whatever case that they might have. It also helps, data engineering also helps to remove errors, inconsistencies, or inaccuracies from data sets. So sometimes data engineers might undertake the role of creating data pipelines that essentially clean data, or ensure that data is clean. It's in a format that can be used for analysis. It ensures integrity and quality of data. It allows stakeholders to be able to work with large volumes of data that have been stored maybe in a particular data source, maybe in big data platforms like Apache Hadoop. Then, in such situations, data analysts or data scientists may not necessarily want to undertake that task because it may not be the best particular time or the best resource. It may not be the best case for them to undertake that task. So data engineers can ensure that they create those data pipelines that allow for ease of just working within an organization with now big data applications. It improves also, data engineering also improves speed and efficiency. It also facilitates real data pre-processing. In many cases where data is collected in real time, data engineers can create data pipelines that ensure that that data is consumed by other stakeholders in an easier way, or they can ensure that they've created pipelines that just pull data efficiently. For example, they could pull data maybe every day at noon or midnight, and they could also implement mechanisms that ensure that that data is probably using the data pipeline that they've created uses what is called a cache system, where the data that is pulled is stored in a storage that ensures that in the long run, when people are or stakeholders are requesting for that data, they do not necessarily request for a lot of data. It's a whole lot of engineering that happens. So sometimes you might create a data pipeline that sort of makes it feel like you're getting data from an actual data source, but essentially what would be happening is that the data pipeline would be getting data in intervals, which could be good enough for stakeholders. So that data can be stored somewhere, and essentially you are able to make use of some optimization techniques such as those. They would want to be able to implement such. One would need to also learn how to use something like Redis, which is a tool, a cache tool that allows you to be able to have that kind of a data pipeline. So the other cases why it's important, data engineering also helps implement security measures and ensure compliance with regulations, as well as also ensures that an organization is optimizing its computational resources and thus reducing just costs. There are various tools that we could use for data engineering. There are data transformation tools. So there's Pandas, Dask, Airflow, DBT. These are tools that we can use for data manipulation, transformation, or creation of data pipelines. There are what are called ETL pipelines, which have different components. There's the extraction component, which just involves collecting data. Once that data has been collected, then that data is passed still in that ETL pipeline to the transformation stage, where the data is transformed, and after the transformation, it's loaded to a destination. So there's that bit that we're also going to actually build pipelines that implement this architecture, ETL. There's usually ETL, and also there's also ELT, extract, load, transform, or extract, load, then transform. So, but normally, in many cases, ETL, which is a popular choice for data pipelines infrastructure or design, that's what we're going to be working towards in this workshop. Data orchestration tools like Airflow. Within Airflow, you can be able to create data pipelines as well and manage data pipelines and schedule them. So you can think of these tools as one that they provide an interface, like a web application that has the ability to manage just multiple data pipelines, group them together, schedule them all together. So Apache Airflow, Prefect, Luigi are some of those ones. Just learning one normally works best. Like you can work with Apache Airflow and you're good to go. But again, because many teams around the world use different tools, sometimes you just might want to learn one or two different tools. Visualization and BI tools. You could also end up working maybe with Tableau to just visualize data that you have been able to load from after creating a data pipeline. So you could use that to just understand how maybe the quality of data is. So you could use BI tools for all of that, and also to visualize some key aspects of your data pipelines. Cloud platforms, lots of data would be stored in cloud platforms, including the even the data pipelines that you're going to be working with can be stored, actually would be stored in the cloud provider solutions. Like if you have created maybe a script and you want to ensure that it's always pulling data from different data sources on the web, you could use then you'd have to deploy your solution in a cloud platform. These are just some of them, but you can use any. You can actually even just, if you have a computer that's connected throughout to the internet, you could always also have that as your own, self-hosted cloud platform. But again, that's something else that one might end up wanting to undertake later onwards. Those are some of the tools. These are others. So there's also data collection and ingestion. Tools like Apache NiFi, Kafka Connect for real-time data, Flume, and Logstash. These are just a few that we can also get to learn to work with when it comes to also collecting data from different sources, especially for real-time data. Data storage, different types of databases. So we normally say that data analysts and data scientists just need to learn SQL, and they can interact with just relational database, whether it's SQL Server or Postgres or MySQL. Those are usually, the go-to for data scientists and analysts. But for many organizations, but in some cases, they might need to learn a bit more. But for data engineers, it's as if you need to learn all the different types of databases there are, the common ones, whether they are relational or not, because data can be stored in different places. So you need to learn how to work with just different databases. So first, data sources, SQL databases, such as Postgres, MySQL, Microsoft SQL Server, NoSQL databases, such as MongoDB, Cassandra, and Redis. There are also data warehouses that you might also want to get to also learn, which one of a few are Amazon Redshift, BigQuery by Google, and also Snowflake, and also data lakes, that's at Amazon S3 and Azure data lake storages. So those are just different databases, and these are just a few. As a data engineer, you just need to be versed on maybe one or two, maybe let's say for relational databases, you can just learn about maybe just one or two, maybe Postgres and MySQL. Because when you interact with just one or two, when it comes to implementation, when it comes to a project, you just realize that if it's a SQL database, the approach is usually the same. So if there are like hundreds, or maybe tens of databases which are SQL, you don't need to learn all of them. You just learn one or two. Then you learn about maybe NoSQL, just one or two. Then you learn about maybe graph databases, which we haven't mentioned here. You just learn, even just one helps. So that you just have an idea of how storing data in those data sources entails. But yeah, so those are the data storages that data engineers need to learn about, and also they also need to be able to perform maybe what is called batch processing using tools such as Apache Spark, which use distributed computing. We've been hosting workshops on that as well as and seeing how it can be useful for big data analytics. So in some situations, especially where you might want, and you might end up creating data pipelines that integrate with big data tools, then having knowledge of these data batch processing tools also works. And by batch, it just means they implement parallel and distributed computing aspects when it comes to manipulating data. So at this point, we are going to shift towards our practice work just to get an idea of how to build data pipelines using Python. Now, because this is a beginner course, we won't go deeper into, how do you interact? How do you pull data from a MongoDB database or from a Cassandra database or from MySQL? No, we won't go towards that direction. We have set aside workshop solely for each and every of those tools. So we might want to build maybe data pipelines with MySQL and Python. We will have workshops on that or courses on that. The same case with Postgres, the same case with MongoDB. So we won't go deeper into that. Our focus, because we are starting as beginners, we are going to start learning how to work with firsts, pandas. Again, we must have knowledge. We do. I would assume that you have knowledge of pandas if you follow up after work. So pandas, how to work with pandas and build pipelines with pandas and also CSV files. We'll also get data from JSON sources. Could be an API that you might want, or just JSON data. We'll also get to scrape data. So we'll create a pipeline that scrapes data from a particular data source or website. And are those the two? Okay, yeah, I think those are the three that we'll cover in this workshop, just to give you a good idea. And it's because also, next week we also have another data engineering workshop. So, that will build off from where we will have come from. So from this workshop. So, and we'll have many workshops on data engineering as well, aside from the other data science or data analytic workshops or AI workshops that we normally have. So yeah. All right, so let's go to the description link, click on the practice resource. It should take you to a page that looks like this. It looks like this. So once you get here, just click on the sample resource link, and it should take you to this particular sample notebook. And this sample notebook only has 2 challenges, and you don't get practice work. But again, if you want to become if you want more challenges as well as a solution notebook and access to all the content that we've ever created for learning, just consider becoming an Afterwork member. So let's get started. Make a copy of this notebook by going to file, then save a copy in Drive. So here it should open a copy in a new tab, and then we can get started. I'll use the practice notebook for this workshop. So I'll use the practice notebook and I'll use it in playground mode. You don't have to use it. But if you're an Afterwork member, let's get on to the practice notebook. All right. Starting off, the first thing that we need to do once we've created a copy, let's connect our notebook to Google servers. And I would want to explain something else. For this workshop, we're generally learning how to create data pipelines with in a notebook environment. But generally, your data pipelines would be in .py files, so Python files. But again, you can still create data pipelines here. And the idea is that once you have gotten the code that we are going to write, you put it in a .py file, you can upload it somewhere in a particular server online and use a task scheduler or an application that normally executes files within a web server. So a web server would be that computer that's located on the internet, and you have an operating system in that particular computer. What would happen is that you would upload your .py file to that computer. You can put it somewhere within any sort of directory that you want, and a tool that you would need to install in that web server that allows you to perform just task scheduling is what is called cron jobs. You can create what is called a cron job, but you usually use that tool called cron, and it would check every minute, every hour, or you could actually create. So when you have that cron tool, what it does, it allows you to just schedule when you want to perform a particular command. So you can write a command and create what is called a cron job and tell cron to execute this command after every 3 hours or 2 hours or 2 hours and 59 seconds, whatever time that you'll have set in that cron job. So your command might be that execute this Python file every 3 hours, and that Python file would have your script, your data engineering script, and that script can be collecting data, transforming it, and storing it somewhere for other stakeholders. And that somewhere can be maybe in a database somewhere else. It depends. It depends with whatever case that you might have. So the code that we are going to be writing here will be just for learning purposes, just to get us quickly started. But I'll make sure in future workshops, still in engineering, data engineering, that we are able to also save or work on our code locally. That way we can be able to get some experience that's really close. It's actually not really close. That's actually what you might end up doing. But yeah, we'll have many workshops. If you haven't subscribed. We'll have many workshops on how to work with generally data pipelines. So let's create a simple data pipeline. So a simple data pipeline. So a data pipeline would just generally refer to just some sequential steps that you use to be able to pre-process data, actually extract data, pre-process, as well as load the data. We mentioned when we are creating a data pipeline, you can think of it as one that performs these three components. It performs these three tasks. It extracts data, it transforms it, and also loads it. So what we are going to do using Python, we are going to create a function. A function is a group, it's just a group of code that performs a specific task. So we will create, not even, it's just a set of code. So we'll create a function that performs the extraction process, another one that performs the transform process, and another one that performs the load process. So this is just really easily explained. So here we have a function called extract. We use the def keyword for that. If you are not sure what functions are, Python fundamentals, by the way. I should actually create a functions session just to get you quickly started if you're not sure. We'll be working with lots of functions. Actually, data engineering will just, it usually involves just functions. So, and you will, when you review other people's code, you'll be just seeing just functions everywhere. So yeah. So we've created a function here called extract. It doesn't take anything. So it has inputs, and inside it, we have this variable called Jane, and not variable, value called Jane, and we store it in name, and we return it. So that's the extract function. And here normally what we can do is just collect data from different data sources. And once we've collected it, we pass that data to the transform function. So here we define a transform function. This function will take data, some input, which will come from extract. It will be the one that will be returned here. And it will also now return again. But again, here we would perform some data processing tasks. This is just for ease of explanation, taking baby steps. So after that, we load the data. So we define now the load function. So we take data from the transform function. And here inside the load function, we perform a task. So here we're just simply printing out the first name, or the name that we got here. And then we define another function called data pipeline that now simply outlines how data flows. So inside that function, data pipeline function, we are getting the extract function. We're actually calling this function. It's running, and it's going to return Jane, and Jane will be stored in data. Then once Jane is stored in data, we then again in the next line pass Jane to the transform function, and again we call the transform function, and the output of that, which would still be Jane, will be stored in transformed data. And then transform data, we pass it to load function, and inside the load function we are just printing, and we are calling just the load function as it is. We are not storing it or anything. And yeah, so that's what we are defining here, how our data pipeline will be. And then we execute the data pipeline by calling now the data pipeline function. So if I run this, I'll get first name Jane. Let me run this. You can see. So generally, this just gives you a good idea of the steps that you can take when it comes to creating a data pipeline. And we are going to be building off this, even when it comes to building data pipelines for interacting with specific data sources. Maybe we want to interact maybe with data, maybe a data source like Postgres, pull data from Postgres, and also pull data from CSV. That process of pulling data, the code that we're going to be using will actually be located here for extracting data. Then once we've extracted the data, we pass the data to the transform function, which performs data preprocessing. It can merge. It just ensures that the data is in the format that we want. Once we do that, we can then pass it to the load function. The load function now can define its own data source somewhere, and then it can store it somewhere. So once we do that, we execute it. So just note that there's a challenge there that you can try. For the sample, we have two challenges, 1 and 2, but for the third and fourth, you could always consider again becoming an after-work member. I hope I hope you've been coming for these workshops. If you have been coming for these workshops often, there's nothing more that you can be able to gift yourself than just being able to have all the resources possible. Okay, all right, pause the video and then work on the challenge. Then we can continue. So here we've just learned how to just create a simple data pipeline. The next thing that we're going to do is to create now a CSV data pipeline. So what we're going to do is to extract data from different CSV files, then perform a basic data transformation task. Then after that, we're going to store that data in another CSV file that can be accessed by other stakeholders. So let's see that. So here we are again defining our extract function, our transform function, our load function, and our data pipeline function. So as you can see in the extract function, we are getting data from these two data sources. So we are reading the first data source will store our data in employees variable, and this other read CSV function will store data in departments function. So here we have two data frames, and we return them. So in functions, you can also return multiple values, not just one value. Like you know, in transform function, we are returning one value, but you can return multiple values as shown. Python fundamentals of so yeah. Once you've gotten to have defined that, so we know that we're going to be getting employees and departments data from the extract function. So the transform function will actually get two inputs. So that's the employees and departments, and it will merge them. So we use the pandas merge function to be able to merge those two functions based on the department ID column. Then after that, we store the merged result inside merged data, and then we again return the output of that, and we will pass it to load data, and that data will again export it in a CSV format. You haven't gone through data wrangling with Python workshop on how to export data, consider that. And we export it to merged data. We set index to false because when you're exporting data sets in pandas, they usually adds another column, an index column, but we don't want that. And yeah, and that's it. And we have merged data.csv. Let me see if I can. Yeah, so here okay, let me just go back to where I was. So here I will come back to that step I was going to. So here we have our two data frames, the merged one. The merged data would be stored in this CSV, and the CSV file will actually be stored on the left hand side. So here you will find the CSV data set around here. Then we create the data pipeline. We define how we want it. So extract function actually returns two values, so employees and departments. So we store the results in these two variables, and we pass the two variables to transform, and then store the merged result in merged data, and then we call the load data, and we execute the data pipeline, and we should see. Now, if I run this cell, and you can do the same, you'll see our due data set over here. Okay, PD, we need to, oh, I forgot to do one thing. You need to run this cell, import pandas as PD. So go up there and run this. It's a pandas data frame, pandas library. So that's where we are getting an error there. So run this. Awesome. So it has run, so you can see check. But if I click on the refresh icon over here, I should see the data set, merged data. You can download, but in Colab, you can even see the data set by double clicking it. You should see it on the far right. So you can see we have employee ID, name, and department ID. So these are just, this is the merged data that we have. And in some cases, you can even just, even in this case, you could have even sorted by employee ID before exporting. But again, this is just for learning purposes. All right, at this particular point, pause the video and then go through the challenge. JSON data pipeline. So this data pipeline would get data from JSON data sources. It could be, maybe it's an API somewhere, an application programming interface. That is, web applications sometimes allow you to access the data behind those web applications through the use of endpoints, which are called APIs. And each API has its own way of just interacting with it. You just need to go to the documentation. But for ease of learning, this is just a quick, easy one. So you can click on the link and follow it. It should take you to a page that looks like what you're seeing here. So what we have here is just simply a JSON document. Some APIs would actually throw this at you. They'll give you this data if you have access to that data. But again, as mentioned, APIs have their own sort of, they've been designed differently, and you need to go to the documentation. Sometimes you need to create some authentication details. You need to create an account with them, then get an API key, then set that up. Still, it's a long process, but that's not what we are really focused on. Our focus is on assuming that you have already access to that data, assuming these are the two different endpoints. Maybe you have one on employees and another one on departments. How do you combine them? So we've seen for employees, so this is the employees JSON data that we have. And we can also have maybe departments data. So this is also departments data. It has just ID for each department and etc. So you can see that. Yeah, so let's merge those. So here we are reading the data, then returning it, the two data sets, and then we are taking them to the transform function, and we merge them. We use the left on, using a left on parameter, using department ID. We'll do a left merge, left join, and after doing that, we also select the data that we want. We may not want to work with the entire data set. Actually, this is merged data. This is what we have, but we select the entire data set that we have. Not the entire, just the columns that you see here. And we set the new column names, which we give here. And now we give back, we return the data from the transform function. We return and we store it in a CSV file, as you can see here. It could also be in another JSON file, etc. that you want. And then we create a data pipeline and execute the data pipeline. All right, so we should see here, if I refresh, transformed JSON data. All right, pause the video and then work on the challenge. In some cases, we might want to maybe create a data pipeline that pulls data from maybe just a data source and maybe a website and performs some pre-processing techniques. So here we are going to be creating a data pipeline from scraped data. So it's generally would be a script that we've created that automates the process of extracting information from websites. It could be one website, multiple websites, but for ease of learning, we just have one here. So we'll import the required libraries. This library called requests, usually we would use it in web scraping. It will actually get the web page that we want from a particular URL, which is what we have here. We use it to get that particular HTML document. Then we go through, or we pass through, or extract, or just go through the entire document using Beautiful Soup. This is the other library, and we are able to extract specific details of the document using Beautiful Soup, and we can define the specific HTML tags that we want. HTML websites are normally made up of web pages, but each web page is normally written in what is called HTML code, and the code itself has tags. So we use Beautiful Soup for that. If you realize it's a lot that I'm saying about tags and you need to learn about them, don't worry about it. We'll cover that in another workshop. But for now, even the challenge won't cover so much about the tags, but just know that the code here that you see here extracts the books that we have here from this website. So if I click on this link, so this is the website, it will extract the title as well as the price. And that's what we want. So it's extracting title, price, as well as the star rating, the rating of that book, each and every book in that web page. And then we store it in book containers. No, we store that in books, and then we return that. From the now this is the extract function that's doing all of that, and then we transform now that data from that we've collected into a pandas data frame, and then we we store it, we again perform some transformation processes. Here we are simply removing the pound, the English pound sign, which is for price, and we are also converting the column rating into numeric column, and we return that and we store that in books CSV, and voila. So if I run this, I should be able to see the book CSV over here. What's happened? Oh, request. Sorry, I did not run this as well. So if I run this again, it should work. Okay, so I can, okay, it's not working. It says A51. So what I can do, I can just remove this, just for learning, just remove that line and run again. Okay. All right, I should have seen this. I should have actually worked towards ensuring this example. Okay, let's just not perform that entire processing. Let's just perform this just one step. So yeah, so refresh that and you should be able to see the books data. So you right click and you should be able to see the data over here. All right, pause the video and then work on the challenge. All right, so next steps. What should you do after this workshop? I think the idea was just to ensure that you have a good understanding of what data engineering with Python entails. The next thing that we would recommend is that you go through the next phase, which would be just working with creating data pipelines using now Python, as well as maybe a data source such as MySQL or Postgres. And our focus will actually be on one of those workshops, which will happen next week, and get to learn about how to create basic data pipelines from such, maybe pulling data from a MySQL database, transforming that data and then storing it in a different MySQL database. How do you connect and do that? In some situations, also, how do you optimize that whole process? We'll cover that in the next workshop. If you did love this experience, be sure to give this video or course a thumbs up. And if you'd want to be informed when we post such courses of the future courses that come after this one, be sure to subscribe. All the best in your learning journey, and see you next time. Bye-bye.